As you see, this is my Rhino screen and Grasshopper screen. I'll be talking about basic stuff about graph mappers, and let me switch to perspective. So what is a graph mapper? A graph mapper is a component that can be found under input and under parameters, under input tab here graph. And if you zoom into that, you see nothing and it says floating parameter graph mapper failed to collect data. If I right click to this, we'll see graph types. For instance, if I say Bezier, it will create sort of a Bezier curve control points in which this can be used to create, or this can be used to manipulate the geometries that we are going to work on. However, they are not limited with Bezier. You see a bunch of different options here like conic, Gaussian, power function, sine function, sine summation, and so on and so forth. But let's stick to this one for now. And as you see, if I double click to this, what I'm seeing is x0 is 0, x1 is 1. So this is basically can be thought as domains, right? And when we see domains, what we usually do is we usually remap those values based on those domains so that whenever we change anything in terms of, in this case, geometrically, they will be changed between 0 and 1. But since we would remap those, it will change the things that we want to change in the right numbers or in the right mathematical formula. So let's think about, like, let's create a curve that has this kind of a geometry. In order to come up with a curve, what probably I would be needing is kind of series, right? Like some sort of numbers here. But let's grab our point component, construct the point, and let's construct, let's say, 100 points. Okay, and let's construct them on our x-axis. So what I'll be saying is I'll create sort of a series. I will have 100 points and I will have my count as 100. So it's going to start from 0 and goes to 100 in. You see, seeing them here, but a small issue. So okay, zoom in, but they're super small right now because the step number is 1. So why don't we have it as 102? And now we have a bunch of numbers here and they are created as points. As I said at the beginning, what I need is I need to convert these points, convert these values in between values, or convert those values into values that I wanted to change in the z direction. However, first I need to divide this graph into the number of points that I'm having. And to do so, I'll go and grab a range component to show you how. And when I connect this, my number of steps is 10 here, as you see. And you see it's divided into 10 with this red lines here. And when I take these steps and put that instead of 100, if I say 99, what I'm seeing here is basically 99 different values. However, I don't see them here because they're too much for this. But if I create a panel and connect that panel to here, what I'll be seeing is I'll be having 99 values. Now I'm having 100 values here. So if I put this in, so how many points I have? 100 points. How many values I have? 100 values. So now the next thing or next step is to basically take these points and connect their values onto a remap version of them. So I'll grab a remap here. So what I'll be doing, I'll be needing for remap is the value. Value to remap is this. And my source is 0 to 1, which is 0 to 1 because my range is 0 to 1. And my target, create a target domain. I'll go and grab a constructor, and my target is now going to change, let's say 0 to 100 or 1500. And when I put this as my z value, let's say I'll connect this to my z value, you see now I started to see my points are going to be following my graph map, the points which we create by using this graph mapper. And if I right click to this and if I select, let's say, sign, and if I pull this point in, you see I can create these kind of curves all over the place. And what I can do here is basically I can convert these points into a curve by going under the curve menu. And under spline I can say interpolate curve or NURBS curve. Basically, these are the ways that we create curves by using points, and very similar to the methods that we see here, like interpolate points, control points through curves, and so on and so forth. So these are our vertices, and it's asking about degree, periodic node style. These are the technical details that we don't need to worry about right now, okay, for the sake of this exercise. And if I preview off these points, what I just see is these curves. All right. So what I can do a contrary curve over here, and then we can loft them to create sort of a parametric roof structure, maybe. So copy this and paste, but this time for the y locations of these points, for the y location of these points, then copy this. So this is gonna be my z's again, and this is gonna be this time this again. But why don't we start like why don't we have y coordinate, let's say, I don't know, something as such. If we do that, what we automatically see is the very similar or very same kind of a geometry is being created here. But what we can do is we can say, okay, do this, or we can take these values and reverse these values. When we do the reverse, wherever it goes up, goes down, goes down, goes up in this case, we can change this, make it larger, higher, lower, and so on and so forth. Like we can increase all these, make all these kind of adjustments. And if we love these two curves, let's see what we are going to have. And this is going to be just a single exercise to show you how we can create. You see, like it's sort of blended inside these two curves here. Obviously, what we can have here is we can do something like this, you know. This could be a roof geometry. We can change it, we can increase it, decrease it, or what even we can do, since we are having this step count here as 100, if we say 500 for both, obviously we need to do that for both. We see that it's going to go all over the place, and I just add this to group, this to this group as well. You see, when we increase the uh, distance between the points, they don't work so well. So why don't we put this like, I don't know, 200? Obviously, we can connect the same input for the same inputs, but for you to see and grasp the idea, I'm using the same logic here. What do I mean? I can connect this over here. What we can do here is we can just easily see what's happening in between. Or obviously you can say, okay, now I want this to go up and down like this. I want them to go up and down like this. So you can create surfaces as such. You can increase the frequencies, and you can basically create a surface like this. And you can to increase, maybe to increase the visuality or to increase how they look. What we can say is we can say divide these curves and divide this one, divide the other one, and when we connect these together by using the line component, we can increase the, you know, how they look. And you see, obviously they are now 10, so if I make them 50, we'll see them in a bit better resolution. Obviously I need to print this off. So that is pretty much, and of course you can change some heights, increase some heights. You can change the minimum domain, not starting from 0. You can say start from minus blah blah. But yeah, I mean, by changing this, you can easily create these kind of surfaces. So to sum up or to maybe recreate what we have already learned, is what we do is basically we go to the proms input and graph mapper to create sort of a graph mapper based or graph mapper controlled curve, what we do is basically we create a series of like let's say series of points. This time our waist is going to be, let's say, 50 centimeters. So what we are going to do is we are going to create 50 points, maybe and by adding them onto like 10 millimeters each. And if I go and grab a vector point, that is going to be my set directions, right? And if you, as you see now, this is my very simple ways. And maybe this view might be a bit big, so I go here, choose options and grid, and instead of grid line count is, I can say 5, maybe too small, 50 is okay. Or you can change the like the line spacing, but this is good for now. So that's basically what. Why don't we now use this? Obviously, I need to zoom in again. Use this as my base and then create sort of ways or set of ways. What I will be doing, I'll be creating a range, and the range, what we have here, like 50 values, we have to have 50 values here, so that I'll be using 49 here, okay? Or what we can do, we can say subtract, and we can connect these two together. So we can subtract 1, so that I'll grab a panel. Because when we use a panel to create a numeric value, it's a static value. It's always taking out 1. When we have sort of a slider, we can forget to move it up and down. So now we have 50 values here. If I right click to this and then say, I don't know, power, you see we have this kind of an approach and with this kind of values over here. And if I now remap these values, this time these values are going to be remapped. Source is 0 to 1, and my domain, construct domain, let's say 0 to, I don't know, like 500, maybe too much, but we'll see. And if I connect this to my x values, you see it goes all over the place. Or if I put this into y values, you see it goes. If I do both, you'll see that it's going to do the same thing but rotate it onto the middle. So we can grab it on the, we can keep it on the x. And when I change this, you see it's being changed. This may not be a really nice graph to work with, so why don't we grab, I don't know, like you see this purling kind of a thing. It's sort of weird. Maybe something a bit further smaller, like visible, like the polarity. This is not something that we really want to deal with. Is here maybe something like this. And you see, I cannot still focus on the view, so I just select this and zoom into this part. So now maybe I can see way better. Okay, now. So what we are going to do next is basically converting this into a curve. So interpolate curve. So I couldn't type it correctly probably. So I come over here and say interpolate, put all these points in and make it up. So how I'm going to convert this into a ways. So if I come over to surface and under freeform, if I select rail revolution, sorry, not rail revolution, revolution, this is my curve and my axis is going to be what? My axis is going to be Z. So I'll create an STL. STL meaning starting point, direction, and length. So if I come over here and then select another point as my starting point, my direction is Z direction, so I can grab a Z vector to make sure things are automatic. And for the length, I can say, doesn't matter, about 50. These are not changing anything. This is just to create an axis. And when I put this in, you see it creates this guy over here. And if I change this, you see nothing is changing. It's basically putting a sort of a circle that starts from here or that centered itself to the point that we create and then move it over. If I put 50 here, you see it comes smaller or larger. Okay. and we can put, I don't know, like another 54 y value as well. Okay, centers itself again based on these value too. So like this is basically how we are creating the surface. However, the good part of this is, oh, by the way, the domain is now basically how we want it to close itself. We want it to now have like 0 to 2 multiplied by pi, which means 360. So we are not going to change this. If you want to change this, so you can say, you can create a domain, like let's say 0 to pi. Factor is 1, 0 to pi. So what we're going to see, you see, it's something as such. Okay. If you want to say 1.5, you'll see it's basically doing something as such. But when we exceed that limit of 2, it's going to be giving us a flag. So you don't need to deal with it. So I'm deleting it now. The good thing, or the fun part of this, is now we can start playing with this, right? And since we have like 50 points, and what we can say is, instead of 10, we can increase this by 50 and started to see how it changes, right? It turns into more like a beer glass right now, obviously, and we can convert it into something as such. And also, like what we can do is we can always um, change this by like copy this and paste maybe, and put another graph type. So let's say sine, and then put that in. You see, it's sort of weird now with the sine values, but you can play around with it and explore more options. Copy this and paste, and maybe create sort of I don't know, like um, like a linear one, and connect it over here, so it goes really like a ways. But maybe you do something as such. It's like more like a can, you know, kind of a thing. So that's basically it. You see nothing now. This is a like empty file. We are starting from scratch. To do so, I can create an STL. This is going to be my backbone for my sculpture, and my starting point of this backbone is this. I can say, I don't know, like say 50 meters, quite high, quite tall. Okay. And usually what we do is basically we divide a curve, right? We divide curve, but this time we can say it divides itself with the same amount of, like, with the same length usually, right? Or we can divide it with a number of length, or sort of lengths that can be numerically controlled. However, how I can use this Grasshopper to control the curve division. So as you already know, I'll create a range. I say 9, which is going to be giving me an 10 values. And let's grab I don't know, like X power kind of a thing, and you see we have 9 different or 10 different values here. And if I again divide this, I will be dividing it, like let's say divide curve, I'll have 11 points, but they're all equal. How I get work around with this? So if I go to curve and underneath analysis, you'll see evaluate curve somewhere here. Yes, evaluate curve is working as like evaluate length. Sorry, evaluate surface. We have to right click to curve and reparameterize. Therefore, we now work within 0 and 1. And this is going to be mine. And if I connect this parameter to parameter, you see now everything is divided with the same amount of values, right? Because when we connect a panel and check these values, you see they're almost the same, right? Almost the same, like changing super small. But if I started to play around with this, what I started to see is I can control where I am uh, having the next point. So if I do something like this, my points at the beginning are very close to one another, and it goes up. the distance in between goes higher. I can do the other way around as well. I can do the other way around. So it starts with a sort of a distance in between, and it gets smaller towards the end. I can copy this and paste and then test another one. For instance, I don't know, like this guy, and then if I connect this, what I'm seeing now, it's a bit like it's a bit sort of symmetric, something that we may not want to have, but we can use this as well. Or we can copy this and paste this and try to come up with, I don't know, like a parabola, connect the parabola to here. You see, when we exceed between 0, when we exceed 1, it doesn't have the point, so parabola may not be a good option. And or like a conic, maybe. You see, conic is working just like x power of x, so we can use this guy as well. Bipolarity, we can use that one as well. So it's completely up to you. Let's stick to this one, and this is basically it for this video. I'll be just grouping this in and then pull out a scribble on even curve. I'll be creating some XY planes on these points, and you see our XY planes. I'll go to curve, and underneath primitive I'll grab rectangle. And if you, as you remember from our previous video, rectangle requires domains to make this plane as its center. Therefore I go to domain, domain, and then like let's say 200, and put the negative value connected over here. And this is going to be my starting domain, end domain, connected here. And when I put this here, see, I think it's quite small, or my planes are quite big right now. Change in size, maybe they are still a bit less visible. Maybe I can edit this to 5,000 and put it in, and increase this and edit this one as well. Okay, something as such. Okay, so these are my, as you see, they are fully controlled by this graph over here. We can still change the graphs like location. Okay, we can still make sure our uneven curve division is working. And my next move is going to be maybe grouping this. My next move is going to be rotating this rectangles. So let's grab a rotate component, and it's going to be asking me this geometry, the angle, and the plane. Plane is going to be XY plane, because I just want to rotate on these XY plane here for this case. The angle can be two different things, right? The angle can be a numeric value that we supply here, or a value that we can use by grabbing our graph mapper. So since I will have this guy over here, I can grab this here, this one. It's going to be 9 all the time, and I can grab a graph mapper, put this in. And like let's put a sine function, and let's remap this value to in between. Our target is going to be something that we want to have, so it can be between 0 and I don't know, 360 maybe. Okay, but before we put this guy into our angle, we have to convert that into radians, to degrees to radians. And what I'm seeing is, now you see they're all connecting and changing in between 0 and 360. And you see they're doing some really slightly changed values here. And obviously if I don't hit here, what I'll be seeing, it's not gonna hit 360, right? It's gonna be changing that one as well. So it goes up here and then comes back. So it's completely up to the user. So what I can do here also is these here, change this, leave it as it is, and so forth. Obviously, if you make this 720, you increase the rotation. But what I'll be focusing on here is not this one only, okay? Because what we can always do is we can always make this rotation in this kind of like XY plane. What would happen if you want to do this on X set or Y set? Frankly, the the logical method is to go around with this is to create the planes that are having these rectangles. But to go step by step, I'll go step by step for each and every rectangle creation. So I will group this and put a scribble and say XY control, XY rotation control, let's say, and put that guy here. Okay, and this might be another group, and this group can be in a different color, and then add it to this one. Okay, and then what I can do is I can copy this, okay, and add to here. This time I'll be creating this. This time I'll be using this geometry as my rotation geometry. But this time instead of XY plane, I'll be using YZ plane. Let's say, and add this to this group and remove this. And then put this guy here as my plane. And now what you are seeing is basically our planes or geometries. Let me preview this off, going all over the place, and you can see the control. So why don't we do the? I'll be connecting this as my angle. So why don't we do something a bit like linear? Maybe it goes too much, and it goes too much. Or why don't we change this angle instead of 360? Why don't we say, okay, just 30 degrees? And that's pretty much it, okay? Or you can say, okay, I don't want to play around with this. I just want to keep it as it is, or just maybe change it as it starts, or maybe I just want to change it as it goes up, okay? You can always say something as such, either. So what I will be doing this time, YZ control, YZ control, right? And what I will be doing this time is copying this and pasting it here. This time I'll be copying this, pasting it as well. This time, this geometry, and instead of YZ, this time XZ. I did this group, put it here. This time it's going to be my plane, and the angle is going to be this. So if I preview this off, you see when I change this, it shifts, it changes. When I keep it as it is, it doesn't rotate as well. But one thing to really, I think, keep things under control is to provide kind of a starting positions. So what we can put here is we can say visualization basically, because these rectangles are our starting point, right? So why don't we say dash pattern? This is the curve, and like let's say 50 as our dash pattern. They look okay. And if I preview dashes, preview off, maybe even larger for the starting, like I don't know, okay. And a swatch, like this is how we start actually, right? This is how we start our everything. And then what we've done is we rotate them. So what we can say is when we rotate those, we can say and group these guys as well. Connect these curves here. And this time maybe we can make them a bit pinkish, just to say, just to visualize them. And like we can go on and proceed with those. But the main idea here is to basically show you how you can control the different locations or the geometries that are created on different locations and how we control their rotation angles. And these are my geometries. And what I'll be using is basically I'll be using scale component. Okay, I'll be using scale component. And these are the geometries that I want to scale. And obviously their center is 0.000, but I can select their center by their area. So if I put this here, you see they're all being scaled by their centers. However, What I wanted to do is basically I wanted to see, okay, you know how you can visualize this, but we don't need to see them now because there are a bunch of things going on. So what I can do here is maybe just to put a factor like 0.5 is here. So how I can put a graph mapper here? I would be doing the same similar thing for having this range component and having it here. Then pulling out a graph mapper, okay. And this graph mapper this time needed to be like, I don't know, like let's say conic. And I'm not using remap because, or this time I'll be using remap because if I don't use remap, this value is going to be changing 0 to 1. 0 meaning it's going to remove what we are doing. But I wanted to say my minimum scale value should be 0.50 and my largest scale is 1.25. Let's say, okay. So this is the range that I wanted to play around with. So this is going to be my factor now. So what I see, as you can see here, what I'm seeing that things are going, like things are going really like large towards the end. But if we change this graph type to this guy, again, you see that towards starting from the bottom going up. Why do we see everything here? So you see that from bottom to top, it goes up and down, up and down, up and down. Or what we can do here is we can grab a sign, kind of an organization, in which we see something as such with the scale. We can do the other way around too, like this. We can really have really minor changes. And you know what? Like this is basically the scale control or size control. Say size control. And when we change something here, they're all being changed, right? When we change this angle, rotations on YZ or rotations on XY, or even like uneven subdivision, we are still following all the same procedure to come up with. And by using this, we can change the scale. Obviously, we can change the scale in different directions, but I'm not going to go in that detail. Firstly, grab and take each curve's actually like height. How we can do that? We can do that by multiplying this value by our height, and our height is this, right? So if I go and to math and multiply this, my height is this 50,000, and it's going to be multiplied with this, and this is, as you see, will work as a percentage, which will give us the exact height, right? So if I come over here and then maybe wire display, right click hidden, so that we are not going to be confused by this. If I grab this over here on top of this, each and every square, or sorry, a rectangle, I can plot this information. So if I grab a concatenate, and these values, when they're rounded, obviously, let's round them, they can be my height. So if I grab a panel, and then say height, sign here, height is this is this, and what I'll be putting here is basically tag. Text tag location is going to be point on curve, so I can put this on point on curve. It really doesn't matter that much, This can be my location, this is going to be my text. I can put a swatch as white, and obviously I want them really tiny. Or what we can do is we can put a tag 3D, as you already know. So we can put this text, we can put an X, Y, Z plane on each point here. Preview this all off. This is my location, this is my color, the size, let's say 150. Is it too small? So we check each and every curve's height by checking this or looking at this one. Of course, you can change the justification as it is, or you can say mid right, mid left. It's completely up to you. So the next thing that I wanted to put as my next information is going to be like this is going to be a group like XY rotation, right? So what I'll be doing is basically get these values, numbers, right? And put this as my second info here. Let me see, we can, oops, these values, sorry, XY rotation, these are radians. So I just need a number or from my degrees. I can right click to this and hidden. I can connect this over here. Let's delete this for a second. And then we can round this as well, round these values as well. Okay. And when we round these values, this is going to be what my XY rotation. So I'll grab here, copy this and paste. XY rotation I would type, and then I'll be putting this in. But what you'll be seeing a problem just in a second. So you see that it's added to the end of the height, right? But what we really want to do is actually go down. So what I need to do, come over here, then you can right click and set a text, but I prefer to have a panel and double click and enter in the panel and click outside, and then you put that XY rotation here as well. So what good thing about this is whatever you do, it's basically being projected immediately. You see the height is being projected, or the rotation on the XY curves, they are being projected, and so on and so forth. So you can control this process, this a bit kind of like a sketchy process onto a bit more precise. And then what I'll be doing next is, why don't we take this all up here, put here, copy this line maker here, and create two other slots, copy this and paste. This time what I'll be doing is having YZ connections, putting it over here as my number, YZ rotation, and put this here, put this here. You see, now I have YZ connections, maybe pushing it up a bit, rolling this here as well, controlling this here as well. Like I'll be doing the same thing for here as well, doing the same thing for XZ. I'm using this time YZ. This is XZ. Let me double check. Yes, XZ. So this value should be this, and when I connect this, it's going to be XZ rotations. And anytime you change these, you'll see some sort of change in between. And last but not least, what I'll be doing is I'll be putting the scale, or what we can put is area. Basically we can say area of this values, or what I can do here is copy this and paste. This is going to be my area value, and this to this group, connected over here, but in the same time just right click to it and hit it, put this guy here. This doesn't need to be hidden anymore, and this is the like a lot of areas here because we are working in millimeters, so I can say area this here, and then maybe the area for each can have it as such. So panels are off a bit, but yeah, now I know. So area is this. Obviously what we need to do, we need to just like take these, like maybe take these 6 out of the areas, like how we can just calculate the distance and then divide that into, I think, let me calculate this. Let me calculate this really. So what we need to do is we need to just cut this here. So we need to divide this, maybe pull out a division and then divide this value first to 1, 2, 3, 4, 5, 6 and put it in, or we just don't basically round this time, and then this is our square meters. And to finish this in a nice array, what I'll be doing is I'll be creating another one, and then I'll be putting a panel and then say square meters and then put it in. Last but not least, this is for each and every curve, right? So we see that for every curve. Not last but not least, this is the controls, and these are the places where we see all the information, so we can also group this as well. And if you love this, we see this like sculpture is being created, but obviously from the top one we just go a bit off, so it's caused by this. So if we can arrange this a bit like slightly nicer, so we can have it as such. So that is basically it for from this tutorial, but obviously why don't we like make this preview a bit better. So it is off, we'll swatch transparent obviously, and we can see this how it goes. Of course, like we can change a lot of things here to make it a bit like a bit however you like. Actually, we can change this rotations, making it up, going down, and in the meantime everything changes on the text values as well when you change something. And like size control, obviously sizes are when sizes are getting larger, square meters has changed. When we change the uneven subdivision, they are also the length, the height are also being changed, and so on and so forth.